Well, thank you so much for the introduction. I'm really glad to be here and be invited to this webinar today. My introduction was pretty comprehensive, so I'm not gonna spend more time on this because I believe you are all interested in the content of the presentation. So here, indeed, it's a slide introducing myself. So this is me, also, so you can give a face to today's voice. As previously mentioned, I am an architect as a background, and also I held a PhD in technology innovation for the built environment. My career started quite early, and the reason why I wanted to stress this is because I have been working in Europe and then also in the United States. So through the education and the research career, I got exposed to different environments, and this allowed me also to have a vision on the directives of this field. Most importantly, what I would like to stress before moving forward, and this is a preliminary message, as an architect, I started to get educated and design buildings, and most of the time we realized that a lot of effort was placed on, and a lot of interest was placed on the technological measures, while at the end we realized that still little was known about the actual effect that occupant behavior was having on the building performance. So little by little, the interest started to grow, and what we can see now is that this is not an innovation anymore, but the connection of how to motivate humans' behavior and the actual energy performance really collide, and it's not innovation anymore; it's current practice, and this is why we end or we start with this project today. So the MOBISTYLE project in a nutshell, so the MOBISTYLE project, it's a very interesting project supported by the Horizon 2020 funding scheme. So I see that here there are a lot of participants to this web meeting. Most of you are from Europe, but I see that a lot of people are also from Canada and somewhere else, and I see Suriname. So so basically, this is a funding scheme from the European Commission, and it's one of the most widespread. So this is a project that started in 2016, and it's a running project. It's an ongoing project. It's a 42-month project, and we are focusing here on motivating end-user behavioral change. How to do this? We try to do this through, of course, ICT support based on personalized information. The key core element here is modularity. In a sense, through the MOBISTYLE project, we are trying to prove that behavioral change can be enforced, for instance, by informing users about their current energy usage, but that's not enough. What is the added value? It's to combine this information in a modular way with other type of data that we can collect from the building, namely, for instance, data from the indoor environment, but also data and feedback on the consequences of being exposed to certain environments with respect to their health, to the health of the occupants. And that's the reason why the consortia that composes this project is pretty multidisciplinary. So we have a representative, of course, of consultants, like for instance, Hagen. We are they're basically a engineer and consultant company. And we design and we consult on building services. But together with us, we have ICT developers that actually work on everything that is connected, so all the ICT part. Together with us, we have a strong component of research institutes that represent different disciplines. And here, for instance, we connect with the Maastricht University, and that is specifically focusing on everything related to metabolic aspects and human responses when exposed to a certain thermal environment or visual environment. And here we have a really strong research aspect that is connected to this topic. We work with a group of anthropologists from Slovenia, and we have to admit that they brought a very strong contribution to the project, which started as with a purely technological-driven vision, but then got hugely inspired by the vision of the anthropologists. And of course, we have also manufacturers such as Whirlpool in the consortia, and the other two partners represent a very also important component, which is energy utilities, providing the validation ground for testing the solutions that we are going to deploy, especially in the residential sector, and also a partner that is expert in gamification, because as you see, part of the project requires the development of a sort of gamified platform to engage users. Okay, that was a very comprehensive introduction, but let's start delving into the project per se. As I said, the MOBISTYLE project started with a vision of what we call the performance gap. Most of you probably already know about it, already heard about it. The interesting part, and that it's also shown in this graph, is that when we think about the performance gap between the theoretical energy consumption, or the consumption that is designed during or predicted during the design phase, and the actual consumption, we tend to think that high performance building will consume probably less than expected, because we tend to assume that highly performing or highly energy performing buildings are occupied by efficient occupants. But what this graph shows is exactly the opposite. It means that typically buildings that are really old and probably very high, very low, at a very low efficiency, are occupied by people that tend to consume less or tend to have a very energy savings behaviors. The result is that the energy consumption in the actual phase, so what you reach from the energy bill, is typically lower than predicted. While in highly performing building, the rebound effect of living in a high performing building and also having, for instance, highly consuming appliances tend to lead occupants to consuming more. So based on this vision, we try to make a switch. So we try to learn, or we try to teach occupants to live efficiently, also in high performing building. But nevertheless, we try to move from the design of a highly performing building to highly performing or very efficiently performing behaviors. So from energy saving buildings to energy saving people. What's our focus? Of course, when we think about poor environmental performance of a building, typically as architects or engineers, we know we can make a full list of the factors that can influence the building performance, namely humidity problems and poor insulation, thermal bridges, and poor performance of the installation, so on and so forth. But still, or little research or little actual implementation of solutions is made when we think about key factors of building occupants, like from the building occupant side, that might lead to a decline in building performance. And here we try to isolate two main reasons. The first one is the incorrect system operation. This means that typically people don't know what to do with their controls because they don't have the knowledge required to run the building efficiently. And this is, for instance, the big issue connected to the thermostat usabilities and the fact that people don't know, for instance, that they don't know how to use the system, basically. The second part and the second factor is inefficient behaviors. And this connects to the lack of user awareness of the consequences of performing certain actions under determined conditions. For instance, people might not know that or might not realize that if they open the window while the heating system is still on, they will lose a lot of energy because all the heated air is going to go outside, for instance, during the winter season. So this is not connected to a purely usability issue, but it's connected, for instance, to the lack of awareness of the consequences. So you can see here that also intrinsically, when we connect to the main reasons why there is a gap between predicted and real energy consumption, and we delve deeper into the behavioral factors, here we can also find an intrinsic dichotomy that connects, for instance, reasons purely technological versus reasons that are more psychological or cognitive. So for this reason, when we designed the MOBISTYLE vision, we try to understand how to design that intermediate layer between people and buildings. And here, of course, we need to focus on the human-building interaction, where building automation and control systems create the middle ground. What we'd like to say many times is that the building ecosystem is efficient if all the building automation systems and the human-related components are mutually conscious. And this means that not only the occupants need to know the building, but the building needs to know the occupants and needs to learn from the occupants. So it's a two-way communication system that it needs to be defined and connected. And this, of course, needs to be supported by sensors, but also by information and knowledge. So the key issue here, or the biggest challenge, remains how to translate the amount of data that we connect and collect from the building into useful information and knowledge for the users and for the building itself. For this reason, we focus in the MOBISTYLE project supported by engineers and anthropologists in the definition in what we call the people-centered approach. The people-centered approach basically has the final objective to develop a platform or multiple solutions that have a value proposition for the market uptake. But these solutions need to be developed and tailored based on users' needs. As you see, it's a 5-step methodology that we can identify or isolate. First of all, of course, the approach starts with the analysis and identification of the target users. Who are the users that can influence or impact the building energy performance? We tend to think, or we tend to use the term occupant behavior, but that's not only about occupants. The performance of a building can be highly influenced, for instance, by building operators, building managers. And these are the stakeholders that we do include in MOBISTYLE when communicating building energy performance. Of course, based on different target users, we will isolate different users' needs, different type of information that needs to be delivered to them. And of course, the different types of features that the platform or the ICT solutions need to deliver to these people. Once the users are identified, their needs are identified, then the developers can start introducing features to the platform. And this is, for instance, what we are doing right now. Once the ICT solution will be ready, then we are going to test the solution in our demonstration buildings. And I'm going to explain to you when, where, and how. So yeah, as I said before, understanding users' needs, it means that we need to understand which are the gains and the pains. So which are the added value or their requirements, and which are the challenges that these figures are, or that these people are facing when using their building. For this reason, in MOBISTYLE, we develop what we call behavioral action plan. This is a plan that has been developed in collaboration with the ICT developers and the anthropologists. So here it's really like a multidisciplinary action plan that has the objective of connecting the optimization purposes of different stakeholders, for instance, the occupants or the energy manager or the building operators, and to define the type of actions that might lead to behavioral change, and also define some scenarios of intervention that can really help them to face the situation that they can enact to start and engage into behavioral change. This might sound a little bit abstract, but I can make an example. For instance, if the optimization purpose for residential users is to save energy, then we can define an action. For instance, you can save energy by closing the window in your room. But also, you can try to avoid opening the window when the thermostat is on. For enabling an ICT solution and also giving tailored information that are timely and contextual, we also need to gather information from the data, from the sensor. So you can understand that then the situation gets even more complex, because it's not just the dashboard that provides reports to the user, but if we want to engage the users in the action, then we need to make this information contextual and timely. And indeed, these are the biggest barriers and challenges that we're facing right now during the development of the solution, the ICT solution. Okay, as I mentioned before, the MOBISTYLE people-centered approach has been supported by anthropology. And this is really interesting because we all know about the concept of user experience, and over the last years, the concept of, for instance, user-centered design and user experience grew out in the realization that technology had the potential to solve many problems, including making information accessible, creating great efficiency in communication. But in that complexity, the technology alone cannot fix all problems. And for that, a lot of organizations started to focus on the understanding on human behavior and how to speak to people in a different way, to gather really thick, important information that needs to be included, for instance, in technology development. Based on focus groups and interviews, the anthropologists came up with the definition of this recommendation, and the ICT developers tried to translate these advices and recommendation in the main solutions that we developed in MOBISTYLE. For instance, the emphasis on the smartphone, the fact that people really like to use smartphones in their homes rather than dashboard. So when we tailored the solution, the ICT solution to engage behavioral change in homes, we focused on a version that is actually available on the smartphone rather than, for instance, just a desktop application. The concept of counter technology is something that is really liked as a concept by the anthropologists. It means that solution to change behavior doesn't need to be intrusive. You don't want to receive 10 pop-ups during the day. You want to have one action that you know that it's relevant for you, and to stick to the plan and to achieve that one action, for instance, for the next week, so on and so forth. All these recommendations are, as I said, have been translated into ICT solution. And this is a scheme of the MOBISTYLE ICT architecture, and basically what it tells is that everything is connected to a core database that connects all the data that we're gathering from our demonstration buildings. We have data coming from white goods, so for instance, smart washing machine that are provided by Whirlpool. We have data coming, for instance, from wearables, in case, for instance, of office buildings, that also collects data about personal information and personal parameters of the occupants. And we have data related to energy and environmental quality that comes both from homes and offices. All these data, as I said, are connected through a secure API to the MOBISTYLE database, and through through algorithms that are developed by experts in behavioral change. We connect to the two main MOBISTYLE solutions: the game and the dashboard. So you'll see these are two different applications that we are in the phase of developing. First of all, the difference between the dashboard and the game is indeed the destination of use. So the dashboard is intended to be used in non-residential settings, and it's intended to be used by building managers and occupants. While the game, as I said, is intended to be used in residential settings. There are key differences, and of course, the type of technology that supports the solution in the backbone is also very different. The desktop application is a web application developed in HTML and also JavaScript, and as I said, it's aimed to the use of consumers and company managers. The desktop application, for instance, has been tested in office buildings of the University of Ljubljana, but also in a case of a hotel in Italy. So here, the hotel manager is able to monitor the performance or the energy consumption of these hotel rooms they're mostly are sort of long-term residents, so we're also able to collect enough data to create patterns of usage of, for instance, electricity and small appliances. And indeed, there is a possibility for the user to see reports, to see stats, and to see energy trends and energy consumption trends. In this case, the purpose of the desktop application is to raise awareness on how to use technology, but also raise awareness of the consequences of energy usage, because there is a possibility of receiving also pop-up information on what to do, or actionable information. And with this information, the user, for instance, can start to enact some of the suggestions and to see the results over time. For instance, if the suggestion is to reduce the 1 degree the temperature inside the room, then the user over a week, over a month, can see the results and the final the results of his or her action. Well, the mobile application, this is also the MOBISTYLE dashboard that is also developed as a mobile application, of course, just to allow people also to bring this information around with them. And if you want, this is published as an open beta version on Google Play. So if you want just to be a trial user, we can provide you with the link and we can just play around. Well, if the other application that we're developing is the MOBISTYLE Game. So here, the MOBISTYLE Game is something very different. As I mentioned, it's purely intended to be used in residential settings. And the scope of the application is to create a sort of a gamified environment that nudges users to take certain actions. The difference with games is, with typical games, is that these actions are contextual and real based on the data that we're monitoring inside the buildings. So these data are transformed, they're analyzed, they're not just provided to the users as in a dashboard, but they're contextual tips that we can give, and based on the actions and the goals that are defined by the users, then the user can receive rewards and badges as such as in a game logic. And as I mentioned, the innovation part is that the game uses the data that are captured from sensors to both trigger emissions and also detecting their completion. So for instance, we place sensors in a room, we monitor the temperature, but also we monitor the temperature, we monitor the state of the thermostatic valve, and also we monitor the state of the window. And then, for instance, we ask the user to lower the temperature and to close the window. If the user accomplishes the task, then we provide a reward. That's the idea. Also here, for the MOBISTYLE Game, we're in the phase of developing the game. And over the next month, we're going to develop a version that can be used, or at least in a beta version, and seen as one of the key results from the project. As I said, in the step of our methodology, once the ICT solutions are ready, we need to test and validate them. And for this, we have very different demonstration buildings that vary from both a geographical location and also destination of use. As I mentioned before, when it comes to residential settings, we have a residential block in Steel in Denmark, and here is a residential building. We have we move from the, let's say, neighborhood dimension up to the city scale. So as I mentioned, there is one of our partners is Sauron, which is an energy provider in Poland, and they provided with a demonstration site which is at the level of the city, and it's in Wrocław. And we also have a residential, pseudo-residential setting, which is a hotel in Italy, which is also a very interesting case, and it's going to provide a very interesting insights. And then we have two non-residential demonstration sites. So one is in the Netherlands. It's Kerkrade, it's an office building, and also we have a university building in Ljubljana. So whenever you're interested, for instance, in to know how these applications work in different settings, please connect to us, and we will be happy to share with you our lesson learned also in these demo buildings. As you see here, the different demonstration buildings trying to accomplish also different objectives. First, in some cases, we are trying to trigger energy consumption reduction in terms of, for instance, in heating or domestic water reduction or electricity or reduction of energy use for the appliances, depending on the demonstration site, of course. A second objective is to improve indoor environmental quality, and of course we also providing with a questionnaire to understand user satisfaction and thermal responses. And finally, we also we'd like to improve health. And here, the connection with the Maastricht University is providing us with the right tools and also scientific knowledge to connect biological, physiological responses to the exposure of different environments that can be static or dynamic, depending on the type of installation, and also depending on the definition of use, residential or office settings. And here also we're trying to develop also some sort of scientific knowledge, since this project, it's not just a purely innovation action that needs to come up with a technology, but also needs to come up with scientific research and publication. So we are going to, at the end of the project, the idea will be also to publish based on these results. And also, of course, to establish user practices. So when we think about how to use the connection of the building with building automation system and behavioral change, then the final scope would be to establish, to change behavior, but on the long term to establish habit formation and in user practices on how to interact with building automation and control systems. Of course, the final step will be the development of a value proposition, and this value proposition should be something that can be actually deployed in the market. Like, as I said, the game or the platform finally would be something that people or manufacturers or the public can use. And we are now in a phase of defining how this platform can be considered open, both in terms of the reuse of the data lake that we are gathering, which is huge, and also how to create a new knowledge based on this modular information that can maybe be solved as additional layer information or used by other companies or other projects for different scopes. And with this purpose, we would really like to be happy to connect with some of your research groups or association to see how we can possibly make better use of the data that we're gathering. But also we're learning a lot of lessons from this. Of course, when it comes to deal with a project with a certain number of partners that have all the different backgrounds, we learn a lot, but also we make mistakes, and then we try to fix them and it's really like a learn by doing process. Here we try to put together some key lessons learned from the projects. Well, first of all, is that energy efficiency and the efficiency of a building automation and control system is at the heart of the European policy and the European, for instance, the Paris Agreement and towards a sustainable future. But most of the time, it's not at the heart of the building users. So people don't really resonate with the concept of energy efficiency. People resonate with different types of messages. People resonate with the concept of having a healthy home or to have a productive office. But and here it's really the language that we need to change and the scope and the objective of behavioral change practices that needs to be shifted. The consequences of this is that people interact with building automation and control systems in their everyday practices, but most of the time the energy that they use remain unnoticed. And also the effects of their actions, for instance, on their health on the long term remain unnoticed. The fact that people are exposed to pure ventilated environments might not be evident if not shown with a sensor or something that is able to show a high CO2 concentration, which is not good for the health of the people living in the environment. So this is the reason why modular information is more than needed. And in a way to make this energy demand visible to users, we need to understand the real type of interaction that people have with the control system. And by this, we need make it visible and understanding what is more important for them and what's their actual practice. And then, of course, interdisciplinary work between engineers and social scientists and inclusion of social sciences humanities. It's not just a recursive echo that we want to listen, but it's really absolutely needed. There is no way out for engineers and technology developers if not through the support of social scientists and people that study and learn and talk to people. And of course, if we start steering new behaviors and promoting practices, then we also see benefits for the building automation and control system industry, because if solutions are tailored for the users, probably users will use it more. They will be more keen on using on the long term, and also the building industry at large can profit from that. Here is my wrap-up, and I would like to give you some key takeaways from this webinar. The first, and it's probably the most important for me and for us, is that the building ecosystem is efficiently only if all the components, so building automation and control system and occupants, are mutually conscious. We cannot think of building a building without letting the users get to know the building itself. That's absolutely important. There should be a briefing or should be a manual for users to use the building. Without that, it's merely impossible to establish on a long-term energy efficiency. The two key factors of the building occupants that might lead to a decline in building energy performance can really be bounded into two main areas. The first is the lack of knowledge of control, and the second one is lack of user awareness. By leveraging on these two aspects, we can solve most of the problems that are now facing, also in terms of technology development. And also, finally, the research and development in the building automation industry should really try to promote solutions and services in which not only energy efficiency is solved, but energy efficiency is a co-benefit together, for instance, with the improvement of indoor environmental quality and health, because these are really the messages people resonate with. So here is the end of my presentation. I hope you enjoyed it, and we can open now the Q&A session. Thank you for the attention. And here you see there are the emails of my colleagues, Anna Tisov, which is a actual coordinator of the project, and also Peter Opteveld, which is our senior consultant, and also the mind behind this project. So please don't hesitate to contact us, and we are also very keen on hearing from you and your perspectives. Thank you.